All right, hello people watching this recording. We are on the last section of the chapter. Yay! Yay! Last section. This is 3-8, and we are rolling right along. Let's go to example 1, and I'll just explain to you what this is doing right here, right? This function right here, x equals 2y squared plus 3y plus 3y plus 1. That thing, if you were to graph it, we are normally used to seeing like y equals x squared, right? Blah, 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 blah. Do you know what y equals x squared looks like if you graph it?
Parabola.
It's a parabola, right? It goes like this, right? If it's a smiley face, it goes like that. But do you know what x equals y squared? Like if they flip the variables around, what will he look like?
It'd be like sine.
Brady did it. Brady did it. This guy is a sideways parabola, right? So he's looking like this, right? That's what my sideways parabola looks like. I'm not making this up, I promise. Okay?
Sine or cosine like that?
What?
Sine or cosine does this.
Don't confuse me, Zach.
Okay? This function right here, negative x plus y equals negative 1. Do you know what that function looks like if you graph it?
That's a line.
That's a line. So we have something maybe going on like this. And what we're trying to do is find where they touch. If this is the case, he's probably going to touch at 2 places, right? Is there a chance they might not touch at all?
Yeah.
Yes.
Yeah. Is there a chance they might only touch at 1 place?
Yes.
Yes.
Is there a chance he could touch at 3 places?
No.
Yes.
Yes.
No.
Not if it's a parabola and a line, right? Like there's no way, like he would have to do one of these in order to touch 3 places. And he won't if he's a parabola, right? Okay? So we're trying to figure out where he's going to touch, okay? So let's do this. Do you guys remember when we would do substitution and elimination? Yeah. Here we have, let's do this. We have we have the x solved for, and we have all this junk, right? Let's go ahead and let's solve for x here. Should we do that?
Yes.
Yeah? Should we solve for x there? Okay. So if we're going to do that, you guys got to be quiet. Shh. If we get x by itself here, let's bump the y to the other side. So I have negative x equals negative y minus 1. Got it?
Times negative.
Okay. Then let's divide by a negative 1 or times negative 1. Some of you guys said. So x equals y plus 1. Yeah? So I have x equals this and x equals this. Let's take this x, y plus 1, and let's plug it in there. So it's like kind of like setting the equations equal to each other, right? Okay? All right, so they've done that here, and we're now down to this step. Y plus 1 is equal to that whole big mess right there, right? Do you see that? Okay? All right, now what did they do?
Minus y.
They moved the y from here over to here. Which variable do you want to subtract from?
The 2y.
3y minus y, yeah? Okay? Can I move this 1 over as well?
Yeah.
I'm going to subtract 1. So if I subtract 1 and subtract 1, ooh, there he goes. What's on the left side? What's over here now?
0.
Nothing. 0, right? 0 equals, I have 2y squared. 3y minus y is 2y, yeah? And then the 1's go away. Now I have this going on. I have 0 equals 2y squared plus 2y. What did they do from this step to this one?
They took out a y.
They took out a 2y, right? They took out a 2y. And then the next thing that they did, I don't like their next step, so I'm going to put it over here. If I have these two bubbles, 2y and y plus 1, 2y equals 0 and y plus 1 equals 0,
Y
right?
equals 0 and y equals negative.
Okay? If 2y equals 0 and you divide by 2, y equals 0. I'm going to put him right here. Okay? If y plus 1 equals 0 and I subtract 1, y equals negative 1. Okay? So those are going to be my 2 places where they're going to cross, at 0 and at negative 1. Do you see that? Now we're not quite done yet.
We gotta solve for x.
We're not quite done yet. We've got to solve for x. I have a couple equations of where I can solve for x.
The bottom one.
Let's put it in this one right here. We know that x is equal to y plus 1, yeah? Okay? In one answer, we got y was 0, and in one answer, we got y was negative 1, right? Okay? If I plug 0 in here, what's the x going to be? 1. If I plug negative 1 in there, what's the x going to be? 0. So I have 2 answers The first one is 1, comma 0, right? If I do x, comma y. The second answer is 0, comma negative 1. Now, these are 2 coordinate points, and what happens at those 2 coordinate points?
That's where they touch.
That's where they touch. So I have my sideways parabola, and he's crossing here, and one's touching there, and one's touching there, and that's where those coordinates are. Does that make sense? Ish? Okay? We're trying to find where they're touching each other.
So do we
Got
have
it?
to, we have to graph?
Not necessarily. No. You just find the equation. You could do that whole process without having to graph, right? I'm just showing you this is what we're solving for.
We're not gonna have to graph them.
No. Nope. I don't think it makes you. Solve the system of equations. You can do that by just substitution or elimination. Okay, let's do a couple more of those. Go down to example 2. Okay, let's talk about what these look like, all right? This is y equals x squared is his parent function. If I get rid of the 5 is just moving him like up 5, right? Y equals x squared. What does that look like? He's a parabola. Is he up and down or left and right? He's an up and down parabola. Y equals x squared. He's going to be an up and down parabola like this, a smiley face, okay? What about this guy right here?
He's gonna be.
He's a line. He's a linear function. So we're looking at that happening. We could have 2 places where he crosses. Is there a chance we could have no places where he crosses?
Yeah.
Is there a chance he could only cross at one place, right? If he's doing one of these, woo, and he's only touching at one place, right? Or he's over here and he's not touching at all. Can he touch 3 places? No. Does that make sense? We could have 1 answer, no answers, or 2 answers. Kind of like when we have zeros, right? Like we're trying to find the zeros, okay? So we're going to solve this guy. They went ahead and they solved for, what did they do? They solved for y?
No, they solved for the bottom x.
I don't like that. I don't want to do that. Can we not do that?
They moved.
Let's do our own thing. Can we do our own thing?
Yeah.
I want to solve for y right here. Can I do that?
Sure.
Okay, so I'm going to bump the x over. Let's add the x. Okay? So if I do that, then y is equal to
A lot.
x plus 7. Now I want to take this x plus 7 and put it where?
Into the top.
Into the top y, right? So instead of x squared equals y plus 5, I'm going to make it x plus 7 plus 5. Do you see that? Yeah.
But it comes up
Okay.
12.
Now the 7 and 5 can make plus 12. All right? So I've got x squared equals x plus 12. Now what?
Subtract the x squared over.
I don't want to do that.
Why not?
Because I always want my x squared to be positive. But you have the right idea, Brady.
X out?
Nope, not yet.
Then just flip the signs.
I'm going to subtract the x here, and I'm going to move everything over to this side. Because I want my x squared to be positive. Do you see that? I always like my x squared to be positive. Okay? So I've got x squared minus x minus 12 equals 0. Now my x squared is positive. Okay?
Now,
We're getting close.
take out an x.
We're getting close. We can't take out an x because the 12 doesn't have one. But what is this thing right here? He's a simple trinomial. Can you multiply to get 12, but when I add them, give me negative 1?
6, negative 6.
Nope, 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 nope.
3, negative 4.
3 and 4. Okay, which one is negative?
Negative 4.
I want it to be negative 1, so I want negative 4 and positive 3, right? Equals 0. But then if I set x minus 4 equal to 0, then x equals positive 4. And if I set x plus 3 equal to 0, then x equals negative 3. There he is, right? Okay. Now I'm not quite done yet. We said up here that y equals x plus 7, right? Y equals x plus 7. That's when we switched to do everything around, right? If x is 4 and I plug 4 in, what's the y going to be? 11. If x is negative 3 and I plug the negative 3 in, y is 4. So my 2 answers are 411 and negative 3 comma 4. There he is. Those are my 2 places where my parabola is crossing my line, right? It's the same thing as what we were doing before with substitution and elimination stuff. It's just we have like uglier equations now, right?
Okay.
But it's still manageable. Okay, let's do maybe like one more and see what we get. That one's going to give me an answer, example 3, so I'm going to skip him. Can I do that?
Don't do number 4. That's graphic.
Number 4, let's not do that one either. Do we have one where he's not going to come out nicely?
Why?
Solve the
That's
system of
graphic.
equations
It looks like we have to go to the homework.
algebraically.
What about 6? Because that's a half.
The homework's
7.
definitely gonna have some
Do
other
6.
crappy.
Example 6.
Example 6.
Yeah, it's like 2x squared minus
One.
y equals 4, and then y equals negative half x squared.
4.
Should we do that one?
Yeah.
Sure.
Sure.
Let's solve it. Some of these are gonna say solve it by graphing, and you don't have to do that if you don't want to. I mean, you can.
I'm not doing that.
Okay, that's fine. All right. What do you want to do with this?
Blow up.
What shall we do? The y is already solved for. What?
Solve for the,
We have this y solved for already.
solve it out.
Can we just take this guy and plug him in right there? Yeah, you sure can. Okay. So I'm gonna do my own thing up here.
But
2x squared minus the y is what we're lumping in there for equals 4. Okay. I've got negative 1/2 x squared plus 6. This one's gonna come out real nice actually. Okay. So I took the first equation, which was 2x squared minus y equals 4, and instead of the y, I put this stuff right here. This is what y was originally, and we lumped him in there, okay? So I've got 2x squared, and then I've got to distribute the negative through. So that becomes plus 1/2 x squared, and then minus 6 equals 4, yeah?
That's a complex trinomial.
Okay, no, it's not. Not yet. This is an x squared, and this is an x squared. They're both x squareds.
So just put them together.
So it's 2x squared plus 1/2 x squared.
2.5x.
2.5 x squared. Okay? Now let's add the 6 over. 2.5 x squared equals 10. Now what do I do? Divide, not yet. Don't square root yet. Divide by 2.5. What's 10 divided by 2.5?
2.5.
I think it's 4. What's 10 divided by 2.5? I think it's 4. Right? 2.5 goes into 10 4 times, right? And then I take the square root. What's the square root of 4?
2.
And
Negative 2.
-2. It's positive and negative 2. You remember, like, from completing the square or from the quadratic formula, we have to have plus and minus, right? Okay. So in one of my answers, I have 2 comma something, and in the other answer, I have -2 comma something. Okay, we have to figure out what the y coordinate is. Let's go to, I don't know, this guy right here.
Plug it
2, 4, and negative.
Heavens. Okay, if we plug 2 in, 2 comma something and -2 comma something. All right. If we plug 2 in here, okay, 2 squared is 4. What's negative 1/2 times 4?
Negative
-2 plus 6.
4.
4. Okay, erase. If I plug in a -2 squared,
4.
is 4. Negative 1/2 of 4 is -2 plus 6 is also 4. Blah. Okay. So 2 comma 4 and -2 comma 4. That's where he's crossing. Yeah, not too bad. Can we handle this?
Yeah, sure. Can I go to Mrs. Olson's room and go get my computer?
Sure. Yeah. Okay. There is the homework. Keep in mind, like, we don't have to do 3, 6, 9, so you might have to run your work over there, right? Because some of this does take a little bit of work.
Can I white out some questions?
You sure can, whatever you want to do. Or just use another paper and attach it.
No, that's
If you want to use a piece of notebook paper and attach it, you sure can. There is the homework. Okay? All right. Good, good? A lot of these are going to have 2 answers.
I'm wearing this.
All right, that is all. Goodbye, people who are watching this video.